I'm just going to teach you the way they tell you, yeah? Now remember the definition that I gave to you, and this is exercise 1G, strictly increasing, and decreasing. The definition I gave to you guys, I said if it's strictly increasing, oh no, that's terrible. Strictly increasing, don't worry, when you watch the video it'll be smooth. So if it's strictly increasing, then the properties were x2 greater than x1 and f of x2 needs to be greater than f of x1. Just wait for it. It should load. Just give it time. I reckon it's going to disconnect at some point. It's alright. Disconnect and then reconnect. Yeah, I know. Alright, this is what I taught you at the time. And what we understood at this point was, all I said was as long as the next x value you choose has a greater y value than the previous one, it is considered strictly increasing. Yeah? And what I said was, depending on the graph, you have something like this, which will take a while. It'll be a cubic shape. We're waiting. It's still waiting. Oh yeah, it came up. So from this point, the maximum and minimum points was the only issue that we had about whether we include the turning points or not. True? And most of us know that where it's increasing would be between. Now I just lost my pen. Where did I put my pen? My digital pen. Did I? I don't know. No. That is a red pen. I was talking and then it just disappeared. This is the greatest magic trick ever.
Oh, it's in the folder.
Oh, it's in the folder? Yeah. Alright. I don't know how that... Voila. Next one. So we say that from these 2 points, what I said to you was that the maximum should be included. Because at the maximum, it makes sense right here. You can see that the y value at this point is greater than the y value beforehand. So I said when you write your interval, you would say you would include this endpoint, but you would not exclude. You would exclude this minimum because the x value or the y value at this point is less than the y value beforehand. Yeah. So I told you it should be open brackets at this point and close brackets here. True. And I still hold true to that by the definition they've given me. I don't think I've interpreted wrong. And that's what I brought to the math staff, and I created chaos down there. And we had to, because on the Google, if you actually Google this, there's like half of them will say what I just said, and half of them will say that it's meant to be open brackets. Actually, no, so it should be a third. A third of them will say should be open brackets only, and a third of them will say that it should be closed brackets, and then a third of them will say what I just said. Okay, so I was confused after looking at the internet, looking at YouTube, and all these people showing proofs and whatnot. It all comes back to this idea, and I still think I stand corrected here, that you just don't include that point. But from what the beaker is, and I've uploaded this document as well, it doesn't matter. At this point, if you know it's increasing, and so where would you call it increasing? You're like, well, from here to here it's increasing, you put square brackets, regardless. Okay, and I find that interesting, because then that basically all it means is if it's strictly increasing, you put square brackets. If it's not strictly increasing, you don't put square brackets at your turning points. That's just how it is. Whether it's endpoints or not, you still put square brackets. Yes? That's how I argue it as well. But so here's the definition that from reading through a lot of Google information and mathematicians, when it comes to increasing, just the word increasing, the derivative doesn't matter. Just increasing, the derivative matters. And basically the property for increasing, they say you only know if it's increasing if the derivative is greater than 0 but not equal to 0. Okay, it's going to come up. What I'm saying is when it's increasing only, so not the word strictly increasing, the derivative, one of the properties for increasing is it has to be positive. The gradient is positive and the gradient cannot equal to 0. Okay? Whereas strictly increasing, it doesn't matter about the derivative. Whether it's a turning point, whether it's a stationary point, whether it's an endpoint, it doesn't matter. The question is, what interval is isn't strictly increasing. And so this is the interval, and therefore this is the interval that is increasing, hence they say you include those points. Okay. Now part of the definition as well, and this is key here, I thought it was nice to sort of look at as it scrolls down, just in this second paragraph here, it's nice to write this down. So I want you to write this property down. Look, I did check through the exams, like a quick summary that Ms. DiStefano did last year, and we tried to find anything that was on strictly increasing, decreasing, and there was only one question in a multiple choice. Other than that, you don't really see it ever again. So I guess it's not too important, but if you do get in the exam hypothetically this year, just keep in mind it will likely be a question on strictly increasing rather than increasing. And there's the second part here that I want you to highlight, or at least remember or understand. They say that if a function is strictly increasing, then it is a one-to-one function. Okay? Which makes sense from what I have here. Between this interval to this interval, it is a one-to-one. If you notice the questions that you did in exercise 1G, when they say prove, the questions they gave you, they restricted the domain to make it a one-to-one for it to be a strictly increasing. Okay? And you also realize that they included the endpoints. So at the end of the day, if you didn't understand what I just said, this is what it is. This is all I'm trying to say in a nutshell. Increasing, if that's the term, don't include turning points. Okay. If it says strictly increasing, include turning points. That's in a nutshell, that's what I'm trying to say. Okay? So write those notes down just so that you know when they say increasing, we don't take the turning point, because that's what Aaron was saying. It's a stationary point, gradient 0. Technically, it's not increasing. That's the definition for increasing. Okay, so definition for increasing has to also have a derivative greater than 0. So this is one of the properties. dy dx needs to be greater than 0. Where strictly increasing, it doesn't matter. It's just which intervals are they increasing. It needs to be a one-to-one. You include the endpoints regardless. That's what they say there. Okay, so I'm just going to quickly take you all the way to this question here, which will take a while to get there. You can look at this document and have a read as well, and they will tell you, they'll give you examples and they'll tell you when it's strictly increasing, strictly decreasing. Yeah? Yes, Alessia? As well. Increasing, decreasing. If it says strictly, it doesn't matter. If it's in an interval, include those endpoints. Yeah, so for example, this case here, if we have a look at it, if the question asks, when is this increasing? Clearly this is all decreasing. It's all negative gradients. But remember, strictly increasing doesn't talk about gradients. We just know it's decreasing right now. All the y values are decreasing, and then from this point to somewhere up here, that's increasing. And then afterwards, after that turning point somewhere on TP, it starts to decrease again. Yeah? So if your question was to ask, where is it strictly increasing, you would say it's between this point, which is likely to be 0, to whatever this point is. Yeah? Now they've given it to us down here, they say it's 1 on root 3 and 0, but notice it's square brackets. So they're including those endpoints regardless. And if you only sketch that bit there, that is a one-to-one. Okay, that's what they're trying to say there. So it doesn't matter, in a nutshell, if it says strictly increasing, you will put in, you include the endpoints. It doesn't make sense to me because it doesn't fit in the definition, but that's how they say it. So if that's how they say it, that's how you're going to do it. And if you Google it, you get different answers. Okay, there's a website called Maths is Fun, and I read through the entire thing. I did the questions for it as well. I got the first one wrong because I followed my definition, and when I followed their definition, you don't include it, you get it right. So just don't trust anything else, just stick with what Vika tells you. So if Vika says that's strictly increasing, then that is how it is. I don't believe in that, but that's how it is. So if it comes up, that's how it is. Okay? All right, any questions on that? Yes, Jun.
Is there an open circle?
Close circle. I put a 0 there. That's meant to be. So close circle, close circle. Next line. Close bracket, close bracket. Yeah. So from here to here, it's closed, never open. If it was increasing, if they had asked for increasing, then yeah, that point is not differentiable, which we'll get to there in exercise 98. That should be open brackets and open brackets there too. Okay, so that's increasing. Strictly increasing, it just literally is wherever it is increasing and include the endpoints. That's how it is. Okay? Which, to me, that they could have said that from the beginning instead of giving us a definition. It doesn't apply to that. I don't know. Doesn't make sense. But anyways, let's go to exercise 9E today. What I'm going to switch the cable so that it doesn't lag.